In this part of the course, we'll examine how to clean and pre-process data using the NumPy package. We'll discuss how to discover missing values and fill them up, as well as ways to remove irrelevant data. Additionally, we'll learn how to sort, shuffle, reshape, stack, and strip data. If any or all of these terms are unfamiliar, don't worry. We'll explain each definition when we get to its designated lecture. Without spoiling all the fun, let's begin with the foundation of cleaning data, dealing with missing values. In this lecture, we're going to focus on several ways to discover gaps in our NumPy arrays. All right. As always, let's start by opening a Python notebook and importing the package. For the remainder of this section, we'll assume you've already done this step. So in the interest of efficiency, we'll skip it. Thus, it's up to you to make sure NumPy is imported at all times. Okay, so one of the ways to check for missing values within a dataset is to use the load_txt function. Unlike gen from txt, load_txt does not just import our data, but also outputs an error message when we try to call a text file with missing values in it. To test if this is true, let's import the file lendingcompany_numeric.csv with load_txt. In case you need a reminder of the syntax, we create a variable that will store the values and set it equal to np.loadtxt. Moreover, we don't write out the entire name of the package, since we imported NumPy as np. Then, within the parentheses, we put the name of the CSV file in quotation marks. If we haven't stored the file in the same directory, we'll also need to specify the full path, but you already know that. Lastly, we need to set the delimiter of the file. If this is a dataset you're facing for the first time, make sure to check its delimiter by opening it via a text editor, like Notepad++. In this case, the delimiter is a comma, so we set the argument of the same name equal to the comma symbol, in quotation marks. Great! Since we don't get an error message after running the cell, the dataset we imported must have no missing values in it. Considering that programmers use many tools to import data in their everyday life, it is a sign of good practice to make sure your data is of good quality in your next step. Therefore, we need a way to verify that the imported dataset contains no missing elements. Lucky for us, the isNaN function exists. This function returns an array with the same shape and size as the one we input. However, every individual element of the original array is replaced with a Boolean value, either true or false. True indicates there is a missing value in that position, while false states the opposite. To see it in practice, let's run this function and plug in our newly created dataset, lending_co_data_numeric. We type np.isNaN, and in the parentheses, we put the name of the variable we defined earlier. The output is a 2D array with false across all the rows and columns on screen. However, the ... after the third row indicates there are more rows not being displayed. Therefore, we can't be certain that the entire array contains only false values. Conveniently enough, there's a simple way to check this. All Boolean values are equivalent to numbers. Every true is considered a 1, and every false a 0. Thus, if we add up all the individual values of the Boolean array, the sum should equal the total number of missing values in the original dataset. To elaborate, consider the following. If false is equivalent to 0, then an array of only false values should be the equivalent to an array of only zeros, right? Thus, if the dataset doesn't contain any missing values, then the isNaN matrix should be exclusively filled with zeros and have a sum of 0. Okay, now that we know what to expect, let's test this out. In Python, similarly to method chaining, we can call a method and a function on the same line, as long as the output of one can be an input for the other. In our case, we want to call the sum method on the output of isNaN. Since the output of the function is an int array, the two are compatible, so we can just add .sum at the end of the line. This should return the sum of all the individual elements of the Boolean matrix. Unsurprisingly, we get an output of 0 here, which confirms our expectation that this dataset contains no missing values. Fantastic! Now, let's try importing a new dataset called lendingcompany_numeric_NaN, which we know has missing values. We're saying no because we manually created this new file by removing values from the original dataset. We can reuse the code where we imported the previous text file and make several changes. First, we can switch the name of the variable to something that indicates missing values, like writing _NAN in the end. Then, we add NAN to the name of the CSV file we're importing. Finally, with the help of a text editor, we check the delimiter of the dataset and set the argument equal to a semicolon. We get a value error because the method reads instances of missing data as empty spaces. The function sees these empty spaces as non-numeric data, so load_txt crashes. Recall that NaN in NumPy is short for not a number, so such values are recorded as missing data. Since load_txt crashes, we'll need to switch to the other NumPy function we use to import text files, gen from txt. Here, we get no errors, so we've successfully imported the dataset. Knowing that there are missing elements within the data isn't enough. Ideally, we'd want to know where they are and what values we can use to fill them. If we run the isNaN method on the new variable, we'll see a familiar sight with a slight twist. We once again have a 2D array with very many false values, but we see one true in the first column of the third row from the bottom. Of course, seeing a single true on screen in this case doesn't mean there's only one single missing value in the entire array. So, we should once again call the sum method to get the total number of omitted elements. A whopping 260 data points seem to be missing from the array, so we need to find a way to account for them before we examine the data further. One way to do this is to pass a value to the filling values argument when importing the dataset. If we set the argument equal to 0 and call isNaN and sum, we'll see that the new dataset doesn't contain any missing values. That is because we filled every empty position with a 0. However, that's not always a great idea, because 0 could be used to numerically represent something meaningful in our dataset. Instead, we should fill out missing values with something that we're certain isn't part of our dataset. By doing so, we can later substitute all such values with something more appropriate. Hence, one approach is to use a number greater than the highest value of the dataset. Lucky for us, we can use NaN max to get the highest value of an array that contains missing values. However, for this to work, we need to reload the dataset without the filling values argument. Otherwise, all the missing values would already be 0, so our efforts will be in vain. All right, we need to store the new filler value for later, so let's create a variable called temporary fill and set it equal to NaN max. Within the parentheses, we'll add the dataset we imported. At the end of the line, we'll also call the round method. Even though this step isn't mandatory, good practice dictates to round values when working with decimal numbers. Lastly, we'll add 1 to this number to ensure temporary fills outside the range of our dataset. Superb! We're now ready to reload the dataset one final time and set all the missing values equal to temporary fill. To achieve this, just set filling values equal to temporary fill. A quick check with isNaN and sum confirms we've successfully filled out all the missing elements. Very well. Now that we've filled out every missing value, we're ready to substitute each one with a more reasonable estimate. In the next lesson, we'll learn how to do this via the where function. Thanks for watching.